Hello, everybody. I'm Zach, and welcome to my NimConf presentation. I skipped out on the last NimConf, and I regretted it for the past year, so here I am. And today I'm going to talk about music, and apparently also about AT-ATs that fart out rainbows. Now, I don't actually know what that even is. I found it, thought it looked cool, so I put it there. No deeper meaning, I promise. Anyway, I'm going to start by talking about my favorite subject, which is myself. I'm Zach. I'm from the US, and I have been using Nim for about a year and a half now and made a lot of little projects. If you've come across any project that starts with para, then I probably made it. I made a game library, rules engine, and various other things. I also made Vim Cubed, which is both my most popular and my least useful Nim project. So I had fun with that one. But anyway, I'm not going to talk about any of that stuff today. I'm going to talk about a couple of more recent projects that I've built that have to do with music. And I'm going to say right off the bat, I don't really know a damn thing about music. I'm not a musician. I never studied music theory. But ignorance of a subject has never stopped me from speaking authoritatively about it in the past. So it ain't going to stop me now. So strap yourselves in, boys and girls. The two projects here are paraMIDI, which is a library that allows you to make MIDI music with normal Nim code. And the second is Ansiwave, which is a full-blown editor, which is what you're looking at right now. I made my entire presentation inside of it, and it allows you to make MIDI music in ANSI art, and it actually builds on top of paraMIDI. So there's some fusion there. But I'm going to start with paraMIDI here. And paraMIDI, when I started working on it, the question I wanted to answer was simply, how do you represent music as code? A lot of people have made attempts at this, and my own belief is that imperative function calls are just not a very good way to model music. Music is really complex and hierarchical and multidimensional. Representing that with imperative function calls, I think, is not the best approach. And instead, I take a lot of inspiration and a lot of design sense from the language I've been using for the past decade now, and that's Clojure. It's the language that I still use professionally. And one of the philosophical beliefs in Clojure is that you should try your best to model your problems as data. It's not uncommon in Clojure libraries for there to only be one or two public functions in the entire library. And most of the functionality is surfaced through data. You create a particular data structure, and then you give it to one of those functions, and it parses it and turns it into something useful. And it turns out this is a good way to model music as well, just simple hierarchical data. And in Nim, probably the most natural way of doing that is with tuples. And I love tuples, guys. Tuples are one of my favorite things in Nim. They're such a lightweight syntax, and they're heterogeneous, and they're can be nested arbitrarily. I think they're a great way to represent music. So this is a simple example. What you're looking at here are enum values. There's an instrument enum, there's a note enum, and there really aren't any rules here about what order can things go in. No, you just put a bunch of stuff inside of a tuple and give it to paraMIDI, and it'll figure out how to play it and what to play. So here we're simply saying switch to the piano instrument and then play these three notes sequentially. Okay, so that's a pretty simple example, but again, there isn't a specific order to things. You can switch the instrument midstream. So here we're saying play a couple notes with the piano, switch to the organ, and play a couple more. So you can mix and match these pretty much arbitrarily. There are also certain attributes. Note length is a common one. You want to make a note drag on a little bit longer, make it a half note. So anytime you set an attribute, it will affect anything coming after that point. But that also means that you can use scope to limit the effects of attributes. So a simple example would be if you only want that note length to affect the D note, well, you just wrap that in a tuple so that the attribute only affects that one note. So scope works as you would expect. And you have to change the note length a lot. So in reality, you don't need to keep writing length, blah, blah, blah. Instead, you just write the number, and paraMIDI knows you're trying to change the note length. And of course, you can change the octave too. That's another common one. And here again, we can just make use of the power of Nim. In Nim, you can certainly do operator overloading. And here, that's what I'm doing. You have this D note, and I'm saying subtract 1 from it. And because of operator overloading, I can just create an implementation of the minus operator. And if you subtract a number from a note, it knows what you're really trying to do is make that one note drop an octave. This will be important later on, as you'll see. Chords are another one where there's just one thing that kind of makes sense and feels natural. Like, how do you represent a chord? Multiple notes playing at the same time. Well, with a set, of course, right? In a set, you have unique values that, we don't need duplicates here because they're playing at the same time. And notes are enum values, so they can easily be put inside of a set in Nim, and it's a very nice terse syntax too. So here we have a chord with A, C sharp, and E. And of course they are affected by note lengths just like individual notes are. So sets are, I think, a really obvious and natural way to represent chords. And because of what we just learned about using overloaded operators to change the octave, we can make chords that span across multiple octaves. This chord has 3 D notes, all in different octaves. And by the way, the minus D is just a shorthand way of saying D minus 1. If you only need to change 1 octave, just do minus D or plus D. But anyway, yeah, this allows you to span multiple octaves. So, we haven't learned that many things, right? Just a couple little, attributes. There are a few more knobs that I haven't gone over, but for the most part, what you've seen here is the majority of the functionality. And that's really all you need. You need notes, you need instruments, you need lengths, you need octaves. But with those simple building blocks, you can make practically anything. So here's a little longer example that I'm sure you'll recognize. And here's an even longer example. This one here is Amazing Grace, and just for fun, I just made it randomly switch instruments as it's playing. That baritone sax always gets me, always hits me in the feels. So yeah, this is what it might look like when you start making more complex pieces. Now, I love tuples. I think this is a very nice way to represent a musical score, but there is one limitation here, which you may have already figured out, And it has to do with the fact that tuples are not dynamic data structures. Tuples are compile time values. Their contents need to be known at compile time, which is fine if you know at compile time what your score should look like. But what if you want to generate scores dynamically based on runtime values? Tuples aren't really going to work here. You need to be able to add notes at the end of your score, for example, or remove notes or whatever. So I thought about this and I realized, well, what I'll do is I'll let you optionally define your score using NIM's JSON module. And, it's going to be more verbose. It's not going to be as pretty, but it gives you dynamism if you need it. So this is the same flute example you see above, but now it's written using the JSON module. And yeah, it's more verbose, especially sets. If you're doing any chords, there are no sets in JSON. And so instead we have to model it as an array where they're set to concurrent mode. So that's more verbose, and also we don't get to use enums with the JSON module. Everything is just a string. But again, it gives you dynamism if it's something that you need. So you could think of use cases for that probably. Actually, Ansiwave uses the JSON functionality underneath because it needs to be able to generate these scores at runtime. So I suppose one obvious use case is games, and a lot of game developers, they use external tools to make their music, and maybe you like doing that, but also as a programmer maybe you would prefer just defining everything with code. And so wouldn't it be cool to also include your game's music in the same repo that your game code is in, checked in and version controlled? And I think that's pretty cool. When you want to go and update your music later, you don't have to go to this external tool and change it and then re-export it. No, it's all right there in your source code. So I think that's pretty nice for people who want to do it that way. And I also think it just makes it possible to do things that are very hard to do with external tools. Like there are some games that actually change the music in response to the gameplay. Where the music is influenced by the gameplay. And to do that, you really do need to be able to dynamically generate music. And there are games that have done this before, but I still feel like it's kind of unexplored. And I believe one reason why is just because it's kind of hard. There are a lot of music libraries out there, but it's still quite hard to dynamically generate complex musical pieces. And this is something where I think paraMIDI would be really useful. So, you can use the JSON API to generate your music at runtime based on where the player is or something like that. So I hope someone tries that and explores that more, because paraMIDI would be a good fit, I think. So there are some longer examples here if you want to check them out in the paraMIDI repo. And there's a starter project which sets you up with everything that you need to start playing music. And because paraMIDI itself actually does not play music, it only generates the waveform data that you can then give to something else that can play music. But I have a separate library called paraSound that can take that and then send it to your speakers. So this project sets you up with everything that you need to get that to work. So check that out. So that's paraMIDI. And so now let's talk about Ansiwave. This is something I worked on earlier this year. And like I said, it builds on top of paraMIDI. But Ansiwave is a kind of a weird little curiosity here. It's it's an ANSI art editor, first of all. I love ANSI art, and I think ANSI art goes together really well with MIDI music. It just fits hand in glove, goes together like chocolate and marshmallows and coffee and donuts. I think they go together really well. And so I wanted to make a tool that lets you do both at the same time. And that's what Ansiwave is. It is an ANSI art editor. You'd have to go into draw mode here, and then you can actually start editing this. I'm not going to do it now. I want to focus on music, and also I don't have a mouse right now. Drawing with a trackpad really sucks. But yeah, it is a full-blown ANSI art editor. But the idea is you can also combine that with music. And the music that you create uses a very simple syntax. It's not the same as Nim. It's a syntax that is designed to, to be pretty accessible, easy to parse. And so here's an example. This is, I think this is the same as the Concerning Hobbits example, but with a guitar. And but because this is in Ansiwave, you can just edit it directly inside of the editor. And the idea is that you can get live feedback as you're typing. So, in this case, I want to go back to the flute, so you can just edit it directly. This is really nice for fast feedback, you write a note, doesn't sound quite right, you hit tab to play it, and then maybe you edit it, you change it, you hit tab again. It's a very fast experience, and you may have noticed that while I was typing there, you have that exclamation point. That's because there's an error. And if you hit tab now, it takes you to this error screen, and it says, well, I don't know what a flut is. So then you go back and you fix it. So, it's like a little IDE basically for making music. And this is, I believe, the Amazing Grace example again, but this time in Ansiwave syntax. So that's kind of nice. But you can also mix your music directly into the ANSI art if you want. So here's a simple example of that. This is a little Star Wars ANSI, and I'll just play the first line. Okay, so, and you can hit the play button on the top left if you want it to play through everything, but I won't do that because it'll go through my entire presentation. But yeah, if you want, you can do this too. You can actually embed your music directly into your ANSI art if you wish. And here's another example. Girl with a guitar, and I will just play one line. So again, you can embed the music directly in your art if you wish. You can also put the lyrics there like I did. And this is the thing. This is why I wanted to create my own little scripting language here, because it's designed so it can just be embedded anywhere in a file, and it can be arbitrarily mixed with artwork and regular text, and there won't be any parsing issues. It can just figure it out. And that was really important to me. It feels like a form of literate programming, I don't want to have to make explicit code blocks and have delimiters saying, okay, now here's where the code starts, here's where it ends. No, I just want to put it anywhere I want. And so that was one of the design goals of it. So anyway, you don't have to do it that way, of course. If you don't even want the ANSI art there, you can just use this as a simple little music programming IDE, and that's perfectly fine. So it's up to you. And finally, I just want to talk a little bit about the future, because I do have bigger ambitions here. Right now Ansiwave is kind of a toy, it's fun, but I have a longer term vision here, which is I want to make basically a modern BBS. And by that I mean a bulletin board system that has the look and feel of BBSs from the past, but is built on modern technologies and you know, you don't have to access it through Telnet or something like that. But still has a retro look and feel. It can still run in a terminal like this. And Ansiwave would be the editor that you use to make your posts. So you instantly have a pretty cool way to make Ansi art and music and share it with other people. And I'm already you know, part of the way there, right? I got the editor. Now I just need to add the networking so people can do threaded discussions. And we have ourselves you know, a little modern BBS. I'm thinking of building it on top of the Matrix protocol, so it could be kind of decentralized. And yeah, of course, written in Nim. So if anyone is interested, I mean, I hate these sort of like vaporware announcements because, you know, I'm still working on it, but I want to just put it out there and see if anyone is interested, and either in helping or in just talking about it. And if that describes you, then come over to the Ansiwave subreddit here, and we can talk about it. Maybe sometime later this year we'll have something usable to try out. And who knows? One day we won't need a subreddit because we'll just have our own little BBS written in Nim. So that's the goal. We'll see if it happens, but I think it would be really cool. And so that's something that I would like to do. All right, so that's it for me, guys. Check them out. Check out the projects. If you're a Nim programmer, perhaps paraMIDI would be more interesting to you because you have the full power of Nim. But you know, with Ansiwave, you have the benefit of, you know, faster feedback because you have this live editor that you can use. So there are advantages and disadvantages to both. And yeah, like I said, join the subreddit if you're interested. And you know, I hope you liked it. If not, then screw you.